The Egyptians used safflower oil as a fabric dye, but it's been modified to create a high-grade biofuel, which can be used and reused as an engine lubricant. Developed with the assistance of the CSIRO, it has zero emissions and high levels of oleic acid, which is used in everything from pacemakers to cosmetics. But as Landline's Tim Lee reports, it's also a handy alternative for grain growers, as the plant's deep roots break up compacted soils.
Petroleum products have oiled the wheels of global industry for well over a century. But they produce harmful emissions in a time of growing concern about climate change. In their search for alternatives from the plant world, scientists may have found what they're looking for in golden safflower oil.
We're not turning the Queen Mary around from petroleum-based oils. We are just coming with a superior product that for the people that are already gone and done the groundbreaking work for us. But we come along with a better product, as is want in commercialisation. It can go into every aspect of where petroleum-based oils are used.
This safflower crop in Western Victoria is part of the plant's Australian resurgence. Safflower originates in the Near East, and for centuries it's been grown in China, North Africa and India. It was used by the Romans and the ancient Egyptians for dyeing fabric, and first grown here in Australia in the 1950s by the paint and resin industries. But this crop has an altogether different purpose. Safflower seeds contain a very desirable compound called oleic acid. A fine, high-quality lubricant is used in everything from cosmetics to pacemakers, and stopping power poles from overheating. Safflower is one of humanity's oldest crops, but there's never been a variety quite like this. It's supercharged with oleic acid.
With an oil content of oleic acid far greater than any other vegetable oil can get to. Sunflower gets to about 80, 85, but it's environmentally affected. If you have a bad season, it'll go down to 70, 75. So you need a good season to get sunflower up to where we are. But with safflower, no matter what conditions, you will always get an oleic acid content of greater than 90% in the oil and the seed.
This paddock is among the first large-scale plantings of a variety developed by Australia's premier science agency, the CSIRO.
In each pod, you're probably going to look at probably 20 to 25 grains that over time will fill. Good. And that's where all your oil is.
It used technology called gene silencing that switches off genes that limited the plant's production of oleic acid.
What it can do is it's replacing high-end oils and stuff like this. So we're finding a replacement for some of those products which are not necessarily so readily replaceable with biodiesels and stuff like that. It's a biodiesel, but it's a very specific special type, high-end.
Compared to a lubricant coming from one of the other vegetable oils and also palm oil, and also compared to synthetic oil, that its performance in terms of reduced friction, reduced emissions from engines, wear on bearings and so forth is way superior.
University trials in the United States have this oil well ahead. The Advanced Fuel Centre at Montana State University aims at developing biochemicals and next-generation fuels from agricultural crops. It's currently analysing this Australian safflower oil. Michael Kleinig has been watching keenly.
Hopefully we can see that.
They're trying to demonstrate that we have produced an oil that's equivalent to a diesel oil currently out there in the market, which has got an SAE 40 rating. Can you give us an overview of what that test involves and what we intend to get out of that?
For now, the properties that we see are looking, it's better than what we see in petroleum.
The test results are a topical subject at the Wimmera Field Days in the heart of Victoria's cropping region.
Back in the 1970s and the 80s, safflower was one of the key oilseed crops that was being grown for human consumption. And then what we found was that the market crashed, basically.
Safflower's resurgence began 17 years ago, when the grains industry and CSIRO plant scientists realised its largely untapped potential.
And really it was out of that initiative that super high oleic safflowers come now back into being realistically a new crop in the market.
The The result is a safflower variety with up to 93% oleic acid, the highest level of purity in any currently available plant oils. The breeding program is getting a further boost here at the Plant Phenomics Research Centre in Horsham. This machine, currently analysing wheat, is also used to analyse safflower. Digital sensors and cameras measure heat stress and growth rates. Varieties are also screened for oil content and quality and subjected to a range of growing conditions.
Like high and low salt condition, different watering to replicate the drought, and also at a different location we are screening for disease resistance as well.
This super safflower is a result of selecting from 400 safflower varieties from around the world.
And we are looking intensely with the genetics of all those genotypes, how genetically they are diverse.
David Hudson, a veteran of Australia's grains industry, has overseen the variety's development and its imminent rollout across Australia. This greenhouse at Melbourne's La Trobe University is screening and assessing countless varieties,
which all have a variety of traits, including different types of oil content, days to flowering, and other traits like disease resistance that are going to be desirable. And we're going to try and use the diversity within those 400 plants to set up a new germplasm collection to generate the varieties of tomorrow.
Though the scientists are in a hurry to breed new varieties, safflower is not a plant that's easily rushed. It flowers on the summer solstice.
Without exception, no matter what time you plant the variety during the year, it will always flower on the 21st of December. So we're trying to trick the plant into believing that it can flower 3 times a year by increasing the day length so that the plant gets deceived.
So plants in this high-tech growing trolley get 22 hours of daylight. Breeding a new commercial variety normally takes a dozen years, but this has more than halved the time. Varieties suitable for dry land or irrigation and a range of soils are all in development. There are some eager farmers ready to try them.
Is not only great for the Australian markets, it's the Australian ingenuity, but also gives us the potential and hopefully possibility to make this even a better crop, because we're only at the infancy of what this crop can actually do, unlocking its potential in oil, unlocking its potential in agronomy.
Safflower can cope with saline and sodic soils, a major problem across Australia's grains belt. The plant's giant taproot means it can be grown in the tropics all the way to southern latitudes.
With the root system it has a very aggressive root system. It can go very deep. And so when you're talking about looking for resources, you're going deeper. So in those dry years, the roots will go down and they'll deliver you some grain, some money at the end of the year, because they're going down and finding resources the other crops like canola, like wheat, like lentils haven't actually been able to find yet.
Those rigorous roots also break up compacted soils, a problem in crops like cotton and rice.
The agronomic benefits of safflower gives to the farmer is fantastic because it's a completely different crop. So you've got a disease break, aerates the soil, uses different nutrients, and so the idea is to actually incorporate safflower in the farmer's rotation crop.
Safflower isn't too fussy about when it's planted.
We're finding we could sow it early and get good results. We can sow it late and get good results. So it's a great malleable crop that's giving us a lot of flexibility.
And so does this oil, high-grade engine oil that can be revamped and reused.
We can take it back, recycle it, treat it, add another additive into it, and we can actually recycle it back into motor mower, chainsaw and those type of oils, which can then be broken down in the environment. So you virtually have a zero or net zero carbon cycle, which is quite unique in itself.
Most vegetable oils go rancid as they age, curbing their lifespan and clogging engines. The scientists have overcome that hurdle.
Getting the stability of the oil up in use has been the big trigger point.
The oil has other environmental advantages over petroleum.
So fully biodegradable, renewable, sustainable. A very good use for it is as a total loss oil, so it greases. Any oil that happens to spill, it will biodegrade in about 30 days, disappear.
The Australian market for oleic acid is a stepping stone into a potentially massive global one. The United States has mandated all government departments, including the military, must move to using plant-based lubricants.
That'll be one of our first initial market entries, and then from there, to get more oil, we just have to contract more farmers. To contract more farmers, they've got to get a good price at the farm gate. So we want to pass all this. This will be great export money for Australia. Royalties back to CSIRO to invest into further, fantastic plant breeding research and whatever else that they want to do there at CSIRO. And then on the flip side, export dollars for Australia. And then we get to, grow the cropping area here in Australia. We want to have a large area here in Australia. And then we want to expand overseas into cropping areas where our markets are. And again, that's still all money coming back to Australia.
So as a farmer, we're very proud of the products that we produce, and to have a product that it needs very little refining, is a biodegradable, is a bioenergy, is a biofuel, is something that can displace petroleum, something that's more of been traditionally used in high temperature, high pressure applications. And so as a farmer, it's a great thing to use that technology and be very proud that I've been a part of a bigger picture.
What that bigger picture will look like, only time will tell.